So this first session is going to be focused on VxRail for GPU-intensive workloads and why VxRail is the best platform for NVIDIA GPU workloads for AI, ML, VDI. We're going to talk through all the VxRail advantages, and then I'm going to hand it off to my friends at NVIDIA, and they're going to take you through some of the exciting new features and capabilities coming on NVIDIA's side that pairs extremely well with the VxRail platform. So why do we think the best HCI platform for NVIDIA GPUs is VxRail? Well, it really boils down to 5 key areas. The first is around the platform optimization and validation. This is all the work we do even before the system gets in customers' hands. The first is our desire to make sure that there's enough flexibility that customers can order whatever platform they're looking for whatever use case they need. Adding in additional configuration flexibility is key to why customers choose VxRail. We support over 11 different platforms with NVIDIA GPUs today, and they are for a variety of use cases extending from general purpose workloads. We have ruggedized platforms that support GPUs that can be used at the edge for AI ML. We have platforms based on Intel CPUs, platforms based on AMD EPYC CPUs, as well as even a 4-socket platform that supports GPUs for VDI dense workloads. So no matter what your use case, it's available on VxRail. But beyond that, we like to extend the flexibility to making sure that we offer the latest and greatest NVIDIA GPUs when they're available. And so that extends to the existing GPU families that are shipping today, but also with the new NVIDIA Ampere-based GPUs, like the A100, the A10, and the A30. All of these GPUs we pre-install in the system, so it arrives to you completely ready to deploy. We ensure that the configurations are validated and have gone through the proper power and thermal guidelines to ensure that GPUs are supported with the configuration that a customer chooses. And then just like we do with all the other additional validation on VxRail, we extend the 25,000 hours of test hours per release to all these platforms that have GPUs in them as well to ensure that the customers are getting the system reliability and dependability that they're come to expect. From a simplification standpoint, we're really looking at extending the experience that with the VxRail HCI system software down to the GPU ecosystem. And that is the one thing the major thing we're famous for is the single non-disruptive upgrade on the hardware and software stack through the VxRail LCM. We've extended this capability. Previously in the past, it didn't have support for NVIDIA GPUs. We've extended this capability with an upcoming release to allow the customer to upload the NVIDIA GPU VIB and integrate it into the VxRail LCM. So previously, you'd have to run the LCM, have that fully automated and orchestrated, and then have to do a second lifecycle upgrade separately to update the NVIDIA GPU VIB. Now it will be all contained in a single upgrade cycle. Furthermore, we're extending additional GPU integrations to VxRail Manager, and this includes additional compatibility pre-checks with the GPU, which will check the version compatibility versus the vGPU software that's supported on the customer system, as well as extending the NVIDIA GPU to the VxRail Manager physical view. So when you go into manage your system and go look at the physical view, which shows you the different drives that you can select and see statistics and updates, you'll also be able to see the NVIDIA GPU there as well. And all this can be supported through automation with our VxRail RESTful APIs. So every operation I just talked about will be supported in our API interface. When it comes to support, a lot of customers are looking and saying, "Hey, when I buy NVIDIA, NVIDIA."
So Ash, does that mean like the CUDA levels and stuff like that, driver levels for the NVIDIA will be in your compatibility matrix and the LCM continuous validation thing?
Yeah, so not the CUDA levels, so anything that's in the ESXi vGPU VIB will be actually included. So basically how it works is similar to how the fiber channel HBA LCM workflow that Don covered earlier works, is a customer will be, as they kick off the LCM, a customer will be prompted with a custom workflow to upload their VIB. And then when it's uploaded, we'll do a validation pre-check, since there's various versions of vGPU software that are supported with various versions of ESXi. we do the pre-check to make sure that the GPU VIB that they upload is compatible with the vGPU version we see on the system. Once we've passed that pre-check and verified compatibility, we will then integrate it into the LCM workflow. So it will actually, when it does all your other updates to vSphere, it does your updates to the iDRAC, the BIOS, it will also update that GPU VIB.
All right, thanks.
The next area where we work together on with NVIDIA is around the single point of contact. That's one of the key advantages customers see on VxRail, whether they have a VMware problem or a VxRail problem, they call Dell Technology Support first, and that will extend to NVIDIA GPUs as it does today, but also all the NVIDIA GPU software. We work very closely with NVIDIA on escalation contacts. If they need to call NVIDIA to support vGPU related issues or any future software related issues, we have a very close relationship with them on the support side. And the final two areas are really around the synchronous release with VMware updates. Daniel spoke earlier about how we release VMware patches, VMware updates within 30 days, within a month, and then express patch updates, security updates within 2 weeks. So all these are fully validated, and this gives customer peace of mind knowing that they'll have the latest and greatest VMware updates as soon as they're available. And then finally, we continue to work very closely, as you can see by this presentation. A lot of the innovations, a lot of the work we're driving forward with NVIDIA is because we're a joint development partner with them. This extends to work we do, in the VxRail Manager, but also the offers we have in our portfolio around NVIDIA licensing for some of their vGPU, vCompute servers, as well as the maintenance offers that can be available through Dell Technologies when you order a VxRail system. And with that, I'm going to hand over to the NVIDIA team to take you through their portion of the presentation around managing AI workloads on VxRail.
Thanks, Ash. My name's Bob Crovella, and I'm joined by my colleague Trevor. I'm on the solution architecture team at NVIDIA. Trevor is in our global account management structure, managing and working closely with Dell. And on behalf of NVIDIA and Trevor and myself, I would like to thank Dell and you all for the opportunity to present to you today. As Ash mentioned, we already have a long history of cooperation and integration in VxRail. And if you look over that history, what you'll see is a pretty strong emphasis around VDI. So the VDI revolution hit probably a decade or two ago. And over time, people discovered that the graphical experience is an important part of the user experience, and VDI really wasn't that exciting without GPU acceleration. And so NVIDIA's been developing GPU acceleration in a virtualized infrastructure, especially including VMware, and we're proud to be a partner with Dell supporting a rich VDI experience for customers who are doing VDI with VxRail. So what's different? What's new? What are we talking about now? NVIDIA's been developing GPU technology for quite some time, and about 15 years ago, we introduced the world to GPU acceleration for general purpose workloads. This is really something different than just a VDI use case where you're virtualizing the graphical interface. Over those 15 years, we've visited a variety of different use cases, vertical industries, and workloads. We started out in the HPC space, and about 10 years ago, we really started to make a mark in the AI computing space. And in those past 10 years, we've continued to invest in this space, and it's grown into a very rich ecosystem with a lot of moving parts, a lot of partners, and a lot of technologies that are all contributing to allow customers to experience AI accelerated workloads. We've developed this leadership position through a variety of technology innovations, and we're proud to report that we are leading the pack in terms of performance for AI-based workloads as demonstrated by the MLPerf benchmark suite. In addition to the low-level technologies and the frameworks that you see in the center of the diagram, we also have application-ready frameworks that allow our customers to quickly develop an AI workload for a particular use case. So for example, the two that we're talking about there, Merlin is our SDK and our API for development of AI acceleration for recommender systems. And recommender systems, as you know, are the things that really personalize and customize the internet to make each one of us have a unique experience. So as you're browsing or as you're searching for movie content or whatever it is you're doing on the internet, recommender systems are constantly customizing the experience. And as we desire a better and more customized experience, our customers are rapidly turning to AI technology to include those recommender systems, to include that in their recommender systems. And this is just an example of the type of AI workloads that's enabled by these lower level technologies, and our performance leadership is demonstrated in the MLPerf benchmark suite. If we look at what has happened, whether we're talking about the HPC space or the AI space or the data analytics space, different spaces where NVIDIA has developed GPU accelerated solutions, right now we're experiencing a lot of silo activity. We're experiencing people implementing this technology, but doing so in essentially a purpose-built or custom-built data center that's designed to deliver that capability or that technology or that workload. And as we look towards the problem of trying to make this deployable in a general purpose way for the enterprise Main Street data centers, there's a variety of challenges that we've surfaced. And one of those is the one that I'd like to point out right in the middle of this slide. That is the complexity of AI solution integration. And if you looked at our previous chart, you might have gotten an idea that there's a lot of moving parts here. There's considerable complexity. It's not really a single stack. It's really a bunch of software stacks, a bunch of technologies that are coming from different places that are all working together to deliver this AI solution workload. And so there's really an incredible amount of complexity and detail in the software stack that's used just to deliver a single AI accelerated solution. And when we approach the enterprise Main Street data center, the IT folks who are in charge of those, they have a variety of concerns. And one of the key concerns is around the complexity of these software stacks and how to deploy them in their regular infrastructure. Another way to look at the problem is to think about the different needs and requirements and expectations of two different groups within our customer base. The one that we tend to focus on is the people on the left-hand side. Those are the people who are the experts in the workflow and the people who are actually creating the solution that will eventually get deployed. And so in the case of data science or data analytics, we might be working with data scientists, and we work with them to demonstrate how our products and solutions and our software stacks allow them to do things like experiment quickly, develop complicated AI applications, and develop an infrastructure that will allow those applications to be deployed. However, when we go and work with the folks on the right-hand side, the IT organization, they really have a different set of questions and a different set of needs. They're interested in how is this going to fit inside my existing infrastructure. I see that there's a lot of silo activity that's been used so far to deploy this, but I need to be able to deploy this using the tools and technologies that I already have in my data center. And I'm going to also need to deliver all those things that I expect to deliver in my data center, like resiliency, security, and management and governance. And so we have to start really focusing heavily on the right-hand side of this chart. And that's really what we're doing now in our partnership with Dell, with VxRail, and in our partnership that I'm about to talk about with VMware. So we're proud to partner not only with Dell, but also with VMware. Of course, we have a relationship that goes back quite a way with VMware, especially when it comes to GPU virtualization. But what we're doing now really is taking those exquisite, curated software technologies that we have developed in kind of like a silo-like infrastructure, and we're now working with the leading provider in the infrastructure management space to provide this using the tools and technologies that the data center operators know how to use and know how to deploy, and the tools and technologies that they're using today to manage their data centers. That's really what we're focused on here, and that's really what this presentation is all about. This is the transition that I'd like to focus on. So just to restate the problem, on the left-hand side, this is what we see if we survey the activity over the past 10 or 15 years. We see that, of course, most of these organizations have a data center, they have IT organizations, and they know how to manage that side of the infrastructure. But we also observe these single-purpose silos being developed that are really not managed as part of the standard management infrastructure. And these are the silos that are being used to deliver these latest technologies, these latest workflows, and these latest applications like GPU accelerated data analytics, or GPU accelerated AI computing, like training and inference. And what we'd like to do is
Robert,
have a solution. Yep, go ahead.
So, I mean, VDI has been around 10, 20 years kind of thing, but it's still a silo kind of environment. It seems kind of, it doesn't seem like it makes much sense to me. I'm familiar with most companies have a VDI cluster or a non-VDI cluster, and I don't understand why that is, quite frankly, because it's all VxRail, it's all vSphere, et cetera, et cetera.
Yeah, I think that's a good question. If you look at where VDI has been 10 years ago and where it is today, I think it's also following this kind of a transition. So if we went back 10 years ago, just like you said, VDI was getting deployed in kind of a silo way. It has a number of unique characteristics. For example, one of the things that we might be interested in a VDI setting is maximum user density. And that results in kind of an analytic process where you decide how much memory does each user need and how much vCPU does each user need and how many of these other resources like networking does each user need. And you end up designing a system according to those requirements. And that doesn't always match the ratios that you've got in your traditional enterprise data center. But using a VxRail solution with a hyperconverged infrastructure, you can essentially purchase the resources in the ratios that you desire to meet those needs. And so I would agree with you that VDI is something that has existed in a silo setting. And we're suggesting that if you haven't done it already, VDI is a great application to move into your data center, managing it using the technologies you're familiar with, like VxRail for scalable acquisition of resources and ratiometric acquisition of resources, and VMware and the other technologies that you're using to manage your data center. That's a good point. So it's also one of those siloed applications. And we're seeing the same thing with data analytics, with AI training, with AI inference.
I understand the AI stuff. It's all framework specific. It's Jupyter. It's got a lot of different characteristics there. But I just don't understand why VDI hasn't been, I'll say, integrated into the data center today, yet.
Well, another one of those resource considerations is GPUs. So not every customer.
I understand it, but you guys have VxRail and GPUs, and NVIDIA have been there for years now, maybe a decade. I don't know.
Okay. Maybe what we can do is continue the discussion. I have my email address on the first slide. It's my last name, robertc@nvidia.com, and I'd be happy to continue the discussion with you.
All right, thanks.
So as you stated, we're eager and desiring that customers will be able to integrate these technologies into the mainstream data center. That's the solution. We believe it's the correct solution. That's what we're depicting on the right. And what I'd like to do over the next few slides is kind of walk through some of the aspects and the engineering that's going in to create that solution between us and Dell and VMware. So this is the chart that we use to try and summarize the entire scope of the development activity here, and really the solution stack. So we often talk about this as a three-layer cake, and I'd like to start at the bottom of this cake. The gray bar at the bottom, you could think of that as kind of the hardware layer. And then as we go through the next couple slides, we'll move up layer by layer and talk about the nature of the solution and the engineering that's going into each of those layers. So at the bottom of the rail, of course, we have the hardware. That's the technology, and that's the area of tight cooperation that exists between NVIDIA and Dell. And this goes beyond merely qualification of systems. In addition to qualification of systems, we have a brand called NVIDIA-Certified Systems. And NVIDIA-Certified Systems means that a configuration, a particular configuration of hardware, such as what you see here, has gone through an additional level of testing, an additional level of certification to make sure that that hardware is ready to go in these data center environments, and to make sure that that hardware is going to deliver the kind of performance that's expected when we talk about GPU accelerated AI solutions or GPU accelerated workloads. And so the combination of hardware here is an important starting point. It includes not only the VxRail platform, but also NVIDIA GPUs and NVIDIA networking technology in order to complete the resources that are needed in this scalable infrastructure. We believe that by providing this level of certification, we can address some of the important goals that we have on the right, like delivering a consistent and expected and predictable level of performance, providing manageability that's consistent with the mechanisms that you're using today, and of course, paying attention to the security and the scalability needs that you have in your data center. NVIDIA-certified testing, as I mentioned, really goes beyond qualification testing. If you think about qualification testing, it's very often focused on a single system. So when we qualify a GPU with Dell in a server, that typically involves running tests that are associated with that server itself, a single server in isolation. However, these workloads, the nature of these workloads that we talked about, these GPU-accelerated workloads, very often involve multiple systems and the networking technology that's used to connect them. So we're talking about scalable workloads, those workloads where you tie multiple systems together to solve a single problem. And we're talking about workloads even like VDI, where networking is an important component of the solution in order to deliver a high level of quality and user experience. And so the NVIDIA certification tests start out by assuming that we're going to be testing in a distributed environment. And that distributed environment is depicted by what you see at the bottom of the slide. So we have two servers connected through networking technology so that we can run distributed workloads that depend on both servers and the networking technology in between in order to deliver the solution and the expected performance. In addition to that, yep.
Can we ask questions? Yeah, I have a question really quick.
Yes.
Can you go back a couple of slides? Because it's going like really quick. One more, I think. This one. Super interested in this slide because it says vSphere with Tanzu. I know that's not a requirement to run AI workloads. So I'm kind of wondering, like, what's up with that? Is it a specific kind of validation that y'all have done? And what do y'all tell your customers when they tell you they don't want any of this? They want to run it on bare metal because they don't want vSphere, let alone a VM, let alone, tons. They want to be able to run it the way they want to run it with their own processes. Okay, there's 2 or 3 questions in there. Let me see if I can click through them, and then you tell me if I missed one. So let's start out with the vSphere and Tanzu question, and actually that's related to the next line below that. So the next line below that you see is containers and virtual machines. And the idea here is that if we look at VMware vSphere historically, it's largely been about managing infrastructure with virtual machines. So if you need a particular machine for a particular user, or even if you need a cluster, you're going to assemble basically a bunch of VMs, and you're going to tie those VMs together using the infrastructure, and that's how you're going to provide that resource to that user or user base. However, the modern, as you pointed out, modern AI workloads didn't necessarily grow up with that kind of ecosystem surrounding them. And so one of the other ecosystems that's grown up at the same time that AI computing has grown up is the containerized workload system. Of course, we're probably all familiar with things like Docker, and there's many other container technologies. But even on top of Docker, we have important orchestration technologies like Kubernetes, for example, to orchestrate the delivery of workloads using containers. And this is an important infrastructure evolution. It's an important delivery mechanism for delivering these AI accelerated workloads. And part of the reason for that is the complexity that I talked about. And so one of the resources that NVIDIA provides is NGC. That's our cloud repository for container images that our customers can freely download and use however they would like. And so those container images contain curated software stacks for the things that we've talked about already, like, for example, for recommender systems, Merlin, for example. We have containers that encapsulate and allow you to deliver a Merlin software stack, a curated, tested, carefully assembled Merlin software stack to your machines running in your data center. And you can do that simply by pulling a container from our NGC cloud repository. And so containerization and the orchestration and delivery of workloads using containerization is an important aspect to this whole evolution. And of course, VMware is well aware of that. And Tanzu is essentially, if I could summarize, is their technology to address the delivery of containerized workloads, and especially Kubernetes organized or orchestrated containerized workloads in their infrastructure. And that infrastructure within VMware can either be
bare metal machines managed by VMware, or it can be VMs running containers and Kubernetes. So you have lots of different options here. But the options are important because this is the way these workloads are growing up. This is the way that people are using them today.
Yeah, kind of. I kind of agree with that. But my question to you is, since y'all are talking about VxRail, and you talked about your own library that is approved and packaged. Is that what y'all have with Tanzu? Is you have a packaged AI ready platform, and that's what is coordinating with VxRail, or is there, how are you coordinating with VxRail?
Okay, so I would like to talk about, I think what you're asking now is essentially what's going on at the top layer of this stack, because that's the way that I would answer your question. Do we have these technologies and how are they being orchestrated and coordinated? That really has to do with the top layer of the stack, which I have a slide to talk about to go into that in a little bit more detail. But the top layer of this stack is designed to integrate with VMware vSphere, whether you're using those containers directly or whether you're using it in a Tanzu orchestrated workflow. Either one, both are supported. And so the key piece of the puzzle, apart from the technology integration from an end user perspective, the key piece of the puzzle that NVIDIA brings to the game in the top layer is those containerized workloads. And I'm going to talk, I have at least one slide to talk about those. So I think we'll cover that topic again, or we'll come to that topic again.
Okay.
So did I miss questions? I'm not even sure I got past the first question, but.
Yeah, I'm not sure either, but it's okay. We can keep going. Okay.
So we were talking about the bottom layer, and the bottom layer has to do with the NVIDIA certification. The NVIDIA certification is distinguished by the fact that it's really testing in a distributed environment. And what are we testing? We're testing those workflows that you see at the top here. So we're not running necessarily just a suite of low-level or synthetic benchmarks. We're running workloads that are consistent with and actually extracted from the containers and the containerized workflows that I mentioned that are available on NGC. So we're testing the workloads that we're offering to our end users, the ones that they want to use to run these AI accelerated workloads.
So is it just those, or are those just examples?
No, it's, let's go to that slide because I think that's going to be important for you. So these are some examples. In our initial release, if you look at NGC today, so I've expanded the top layer here, okay? We're looking at the third layer. We kind of skipped right through the second layer. I'm going to come back to the second layer in a moment. But in the third layer, what you see at the top of this slide in the green box, at the very top of those 6 blocks, TensorFlow, PyTorch, TLT, or our Transfer Learning Toolkit, Triton Inference Server, NVIDIA TensorRT, and Rapids, those are all containerized workflows and containerized technologies which are available today in NGC, and those are basically NGC containers that you're looking at, those top 6 blocks there, okay? And those are the workflows that are the ones that are most commonly used and most highly demanded from our customers. So customers that are doing AI training are going to be using TensorFlow and PyTorch. Customers that are doing AI inference are going to be using the Transfer Learning Toolkit and also the Triton Inference Server and also NVIDIA TensorRT. And customers in the data analytics space are going to be using Rapids. That's kind of a very quick decoder ring for those 6 initial containers or 6 initial workloads that are part of our NVIDIA AI Enterprise software stack, which is the top layer of this enterprise suite offering. In addition, there are additional technology there. So of course, these containers depend on things like CUDA, and they depend on other technologies like Magnum IO, which is accelerated storage infrastructure for GPUs. And they may also depend on NVIDIA vGPU, which is the technology that we use to deliver VDI workloads, let's say. And in the middle there, we have those 2 things called operators. What operators are all about is they're designed to be able to land, if you will, on a system and quickly provision that system, quickly provision the networking and the GPU so that it is ready to go, configured properly to support the workloads that you see above it. And this is very important in a Tanzu or Kubernetes environment where you essentially have an orchestrated workflow. You've got a manager that's distributing containers to machines, and those machines are otherwise basically unconfigured. They're bare metal machines, and so we need to load things like the GPU driver, the networking driver, and other pieces of technology that are necessary to get those machines and provisioned and ready to go. And that's what those two pieces of operator technology are all about. So all of this is part of the green block, if you will, at the top, and all of this is resting on top of the technology integration that we're doing with VMware vSphere.
And Robert,
and
these things,
the best definition of what customers will have through this technology at its initial offering.
and so these things are all really packaged into containers. Is that so? There would be a TensorFlow container that contains all this stuff, and a PyTorch container that would contain all this stuff. Is that the two operators, the four information optimization, infrastructure optimization levels? Is that?
Yeah, so the operators are containers that would normally be used in a sort of a Kubernetes or Tanzu orchestrated workflow to provision the machine. It's software technology. It runs inside of a container, and it does things like loading the GPU driver and loading the networking driver in the base machine, which is a little bit unusual for something to happen inside a container, right? Normally, a container is running in user space, and the base machine would be configured, let's say, in kernel space. I'm kind of being a little bit wishy-washy here. But the operators are kind of unusual technology to be running inside a container that provisions the base machine under the container.
And somehow this is all running on VxRail hardware?
Correct. That's at the bottom of the stack in the gray bar.
All right.
Okay, so I skipped over the layer in the middle, so I don't want to, I think we've spent enough time in NVIDIA certification, and we've talked about the benefits of NVIDIA certification. I don't want to suggest that what we're doing today with VMware is simply a rebranding or a rehash of the things that we've been working on with VMware over the past decade or so. Of course, we have a relationship with VMware that has been very important to our VDI evolution, for example. But what we're doing today with VMware, with the NVIDIA AI Enterprise offering on VMware vSphere, is that we're integrating important technologies that are part of our latest GPU offering and part of the technologies that are used by these sort of cutting-edge software stacks to deliver the highest level of performance. So, for example, our Ampere technologies integrate new hardware virtualization using SR-IOV technology. Our Ampere GPUs also offer, the A100 and A30 in particular, also offer the ability for those GPUs to be partitioned so that you can essentially divide a GPU into pieces and assign those pieces to different users or different workloads. And the reason to do that is because these GPUs have become so powerful that for some workloads, the GPU is not efficiently utilized. It's too easy, if you will, for the GPU to run that workload by itself. And so to get maximum efficiency and value out of the GPU, it's nice to be able to slice some of these really powerful GPUs like A100 and A30 up. And that's what MIG or MIG technology is all about. The third block on this is GPU Direct Rdma. And that's an important technology that allows GPUs to talk to each other in the highest bandwidth, lowest latency configuration. And so when we're doing these distributed workloads and we have to share the work between multiple GPUs, sometimes we have to share the work even between multiple GPUs in different systems, different nodes, different VMs, depending on how you've configured this. And we want to enable this direct GPU to GPU communication because that's what people have come to expect in these siloed installations where they have carefully curated the entire installation to be optimal for the performance of this workload. We now want to deliver that optimality in this managed infrastructure that is deliverable in the enterprise Main Street data center. And finally, of course, we're nothing if not performance. That's the reason people use GPUs in these settings is for performance, and so we have to pay attention to that. And we've done a lot of testing both with us and VMware to ensure that the performance you get, even in a VM, using this technology is consistent with the performance that you get in a bare metal setting. So you're not giving anything up. You're not paying a tax to do this. Yes.
My understanding is MIG's been available on older GPUs, so that this doesn't support that, or how does that play out?
MIG is a technology, is a hardware partitioning technology which was introduced with the Ampere generation, and it is applicable only to Ampere A100 and A30 GPUs today. If you look back historically, it's correct to say that GPUs could be partitioned or shared, let's say, is another way to do it. And of course, that's really what VDI is all about. You'd buy a big, let's say a big GPU, and you'd have 4 or 8 users, or maybe even 16 users sharing that single GPU. That sharing, historically, prior to the Ampere generation, was done using software virtualization technology. And now, as you see on the left-hand side, we're introducing hardware virtualization in order to make that cleaner and more efficient. And the MIG, or multi-instance GPU technology, is unique to A100 and A30. This is a hardware partitioning. This is something where you actually configure the GPU in a particular way, and then that GPU, let's say I divided it into 4 MIG slices, that GPU would present 4 independent devices to the machine and 4 different users. And the partitioning is at the hardware level, which means that if you have a certain amount of memory, the memory is partitioned up by 4, if I had 4 MIG slices. If you have a certain amount of compute units, those compute units are divided by 4, and so forth. Even the memory base is divided.
And what's the address translation under the GPU Direct?
So address translation services refers to the idea that when you're communicating between 2 different processes, 2 different compute spaces, if you will, the address maps in those 2 spaces may not match each other. I may have a buffer that's loaded at address 1000, and you might want to be able to access that buffer, but you've got something else at address 1000 in your memory map. But you'd like to have direct memory mapped access to that buffer. So what are you going to do? Well, there's a variety of different ways to solve that, but the high quality, the hardware accelerated way to solve that is to use hardware accelerated ATS, or address translation services. And the idea is that this will allow at the hardware level, in other words, as the data is being communicated in one process, I ask for the memory at address 2000, but that memory is actually backed by a buffer in the other process, and it goes to address 1000 in that other process.
And these buffers are effectively on GPUs, really, right?
Yes, these buffers would be on GPUs, that's correct.
I got you. All right, thanks.
So the key takeaway, I think, from this slide is, even though we've been working with VMware for over a decade now, this is really a new evolution. We're really putting a lot of engineering into this. Both NVIDIA and VMware are putting a lot of evolution into this new technology that's part of NVIDIA AI Enterprise. And it's really designed to deliver that curated, high-quality, siloed solution that our customers have come to expect when they build one of these siloed resources, but deliver that in the enterprise Main Street data center using the technologies that the IT organization is familiar with. So we've talked a little bit about this slide already. This is the 3rd layer. I've kind of gone over all the blocks of this, but this is really from an end user perspective. In other words, that data scientist, okay, this green block is going to be the thing that's most interesting, because this has the workloads that they want to use to develop AI accelerated and GPU accelerated applications. So this is the last of my slides, and I was going to turn it over to Ash if he's available, and he will wrap up with the value.
Perfect. Thank you. Ash, go ahead.
Yep. Thank you. So the capabilities we're introducing crafts a great storyline, really highlighting, everything we talked about, the joint innovation between VxRail and NVIDIA, and truly embodies what it means to work better together. It really has enabled NVIDIA and VxRail to empower GPU AI ML workloads. We talked through the value on VxRail, we talked through the value that NVIDIA brings, and it provides a scalable platform that simplifies and accelerates customers' time to value. VxRail is going to be the first HCI system delivering support for the NVIDIA AI Enterprise software. And to reiterate kind of the key values that we highlighted throughout the presentation today, it's really about delivering an engineered, validated offering that's built into every GPU optimized VxRail. You're going to have a wide breadth of NVIDIA-certified GPU optimized platforms with VxRail. You're going to have the latest and greatest NVIDIA Ampere GPUs, several of which support the new MIG technology. You're going to have the VxRail Day 2 enhancements that take advantage of the NVIDIA GPU ecosystem. That's fully validated, orchestrated lifecycle management. That's lifecycle management beyond just the hardware software stack, but including now the NVIDIA GPU VIB. You're going to have the compatibility pre-checks to check the version against the NVIDIA GIB and the vGPU software. You're going to have integration into the VxRail manager for physical view, a long overdue ask where customers have been asking, hey, I want to see where my GPUs are. I want to get status on my GPUs. You're going to have tight integration with the VMware software. You saw how we talked about the software is used to enable virtualized and cloud-native deployments of the NVIDIA Enterprise AI software. And then you're going to have rigorous test validation with every VX release that extends the GPUs. And you're going to have a single point of contact to support, whether that's starting with VxRail and we triage the issues, work with NVIDIA to escalate, or going through NVIDIA and their first class support to ensure that your problem is taken care of. Any questions?
I mean, Ash, the real problem is that there's a lot of software stack embedded in those containers, and how much of that, yeah, obviously VxRail and VxRail Manager are not going to be checking the compatibility of those things, are you? I mean, as far as you're concerned, the VxRail continuous validation stops at the NVIDIA driver. Is that how I understand it?
That's correct. So from an infrastructure standpoint, the NVIDIA GPU VIB will stop at the driver for the GPU. We'll still do the full stack validation of vSphere and still do the full stack validation of all the hardware. With VLCM, with the introduction of the VLCM that we talked about, you will have the capability to integrate in LCM Tanzu. But as far as the underlying software stacks inside of that, each of those containers, that'll be managed by NVIDIA.
All right, thanks.
Okay, this is Kristen. I have a question regarding the hardware, so I couldn't see it on the slides. It's just a quick question. Does Dell EMC VxRail support NVLink between the nodes?
The NVLink technology is only available on select platforms. So it's available on some of the DSS platforms on the PowerEdge side. It's available on some of the towers. It is not available in any of the PowerEdge rack platforms. So the PowerEdge rack platforms are what we leverage for VxRail. So no, we do not have the NVLink technology.